Welcome to part 2 of my Android Room database tutorial. My name is Ryan, and basically what I'm going to be doing is building more or less most of an entire application, which is basically just a simple note-taking app. And I'll show you how to build it with ViewModel, LiveData, and Room Persistence Library of Android Architecture components. So that's the primary goal of today, but I just wanted to mention a couple of things before we get started. So first off, what this tutorial is and is not. So first and foremost, I believe I mentioned this in the previous introduction video, but this tutorial is sort of designed to leave off where my RecyclerView full app tutorial sort of left off there. So that means a number of things. Number one, we're actually going to be basing much of the project, including the layouts and certain things, off of the code from the previous tutorial, and that will be our starting point for this one. But that also means other things. I'm going to be assuming that you've gotten through that entire tutorial, and I do have to mention it's a lot more than just a RecyclerView tutorial, because basically what I'm demonstrating to you in that tutorial is the basics of unit testing, general app architectures, and things of that nature. So most of that stuff I won't be sort of going over in any kind of detail as I did in the previous video. So that's one thing. The other thing is that I'm not going to be building any of the layouts on camera. We will be copying and pasting them directly from the finished repo, so I'm not saying you have to write them yourself. But the thing about it is there's nothing in there that's new that I didn't already discuss in the previous video. And it's really quite outside of the point of this tutorial. The main purpose of this tutorial is, of course, to show you how to build a working room database, but also demonstrate how to use, for example, ViewModel and LiveData, and how to use the Android architecture components sort of together. And I'll also show you how to use a very basic, deliberately simplified version, or implementation rather, of Dagger 2, and how that can help us kind of use dependency injection to sort of set up our view models and our repository at runtime. So that's basically it. Just like the main thing is this is more of an intermediate tutorial. So if you're a beginner watching this and you haven't completed the previous let's build a RecyclerView app 2017 tutorial, you're going to want to go and do that. If you ask a bunch of questions which I answer in the previous tutorial, I will make fun of you. So that's it. Hopefully you enjoy the rest of the video. I think it's going to be fun, but it's probably going to be a pretty damn long video because we've got a lot to cover. So to begin with, the first thing we're going to do is you're going to want to navigate to /cove/room-demo 2017, which is the repository for this project, and you're going to want to head to commits, and then scroll down to the bottom, and you'll see the starting point based on RecyclerView Demo 2017 repo, and that will be, of course, our starting point for the tutorial. You're going to want to head to Browse Files, and then using Git, or you can simply download a zip, whichever you prefer, you're going to want to clone this repo and open it up in Android Studio. So as I mentioned before, I'm going to have the completed project open just off to the side, and for the stuff that is sort of basics, which have already been covered in the previous tutorial series, that stuff we're just going to copy and paste it in to save time, because this is an intermediate tutorial and I'm going to be assuming you know how Gradle works, the basics of it at least. So let's go ahead and open up the app level build Gradle file, and I'll just really briefly touch on this stuff. So for starters, we're going to downgrade to Compile SDK version 25. Now, later on, once O is a little more solidified, or if you're watching this tutorial down the road, you can absolutely upgrade that to the more current or chronologically accurate version. Just for this tutorial, I'm going to be using API 25. And so a couple of things. We're not really going to be worrying about product flavors at the moment, so we can go ahead and delete that part. But there is one annoying little thing we need to add within the Android. I believe that's called a Gradle either a Gradle task or a script, but I'm always really bad at remembering arbitrarily named things, so forgive me. So I had to add this in because I was getting an error with the Espresso library. I'm assuming they use find bugs and they have a incorrect version of it or something like that, but this was a little thing that I needed to add in to fix some errors. Hopefully when you're watching this video you won't need to add that, but if you are getting some errors, then this is quite likely what the issue is. For the dependencies, I'm just going to copy and paste the whole dependencies thing from the completed code or completed project. Just like that. And what we've added in is, of course, Dagger 2. Just a really quick note on Dagger 2 is that I'm only going to be demonstrating a very simplified sort of setup for it. I did not want to get into, let's just say I looked at some other projects that use Dagger 2 and Android architecture components, and I wanted to keep things a lot simpler than that because otherwise it would just be too bloody hard to understand and explain. So I'll show you a basic Dagger 2 implementation, and of course we've added in the architecture components and the room stuff, and just for aesthetic appeal we've added in the view pager indicator library, which I'll show you really quickly how to set that up. So that's basically it in the build.gradle, the app level build Gradle file. And then go ahead and open up the project level build.gradle file. And within here we're just going to add a couple of things. So just for the all projects task or script or whatever the hell it's called, I don't really care. I'm just going to copy and paste this in here. So we're adding a Google repository, and also this is for the view pager indicator. And then we're also going to navigate to the bottom of the completed project, and you'll see another task or script or whatever called extension or ext. And all this is just a bunch of constants which we use for our dependency versions here, so that way we're not changing them in multiple places, but only changing them the least amount necessary, which is of course what we want to do because we care about being good programmers. And that is it for the Gradle stuff. Alright, so once again, to save a whole bunch of time, what I've done is I've actually just copied and sort of overwritten the entire res directory from the completed project and sort of pasted it into the current project that we're working on here. And what that's done is it's added a number of drawables which we'll be using. So for example, we have the drawables which we will use in the app to sort of simulate more practical drawables. But in this case, for this app, they're really just colored squares. We've got a couple of icons that were added in. And then also I have added in our layout files. And also some stuff in styles. So as I said, we're not going to be writing this stuff by hand, but I'll just take you really quickly through the different sort of feature layouts. So my activities, as usual, are simply just containers for the fragments, which are the views themselves, and they just look like frame layouts. For the fragments, we have fragment create, detail, and list. So fragment create is simply a layout which has a view pager up here. It's got the pager indicator down here, and just an edit text box for users to enter the message that they would like to include in their note. For fragment detail, it looks the same as the previous tutorial. It's just sort of an image view and two labels or text views. Top text view being the date that the item was created, and the bottom being the message which was written. And nothing really special going on there. And then we've got fragment list, which is simply a recycler view, and also a floating action button. And all of these three fragments have sort of a fake aesthetic sort of toolbar, but it's really just for aesthetic appeal. And that is it for our layouts. Of course, we've gone over the drawables, so that's pretty much it. And there were a few things that I added into styles down here, but as I've said several times now, it's really not the focus of this tutorial, so that is that. Alright, so now we've got all of that obnoxious copy and pasting done, and we can start getting to the important stuff of this tutorial. So what we're going to do now is just lay out our package structure. So from the previous project, we had the data, logic, and view packages, and that was basically the entire application. Well, we're going to keep the data package, but we're going to change things quite drastically outside of that. So I'm going to have you add a number of different project folders here. So we'll start with create. And basically what we're adding is both features and layers of the project. Some people like to do package by layer, some people like to do package by feature. I actually blend both of them because that's what makes sense to me. But you can really lay it out however you like, except that I really do suggest you put the sort of feature-specific classes like the list activity and list fragment in one package, because it really doesn't make sense to disperse them. So we've got create, we've got detail. I'm going to change view to list, so I'm going to click on it, hit Shift F6, and we're just going to change it to list. And what else have we got? We're going to add in a package called util, which is kind of where I put, it's kind of the everything drawer of the Android application. And we're going to add another package called ViewModel. We'll talk about that later. And we've got data. What else do we need? Logic, data, create, list. And we, of course, need our dependency injection package. And let me just double check that that's everything. All right, and for logic, we're actually just going to delete that one there. We don't really need that anymore. And so that is all of the different packages of our project, and we'll kind of just dive in here. So before we carry on into coding the database itself, I just wanted to briefly revisit the architecture and talk a little bit about Model-View-ViewModel and also how Room itself works. So to begin with, one issue I had in learning Model-View-ViewModel as someone who has built the past 4 applications, I'd say, in Model-View Presenter, is that I did not find it to be a very well and consistently defined pattern. And what I meant by that is you can find about as many ways to sort of build a Model-View-ViewModel application as there are developers. So what I tried to do was really boil it down to the most basic sort of fundamental principle. What exactly is Model-View-ViewModel? And really the best that I could do, and largely what I'm basing this off of, is actually from an article written by Martin Fowler, and I'll just link that in the show notes down below. But basically the fundamental concept, and please forgive me if I'm not going to say incorrect because it's not something that's well defined by most people, but if you have a differing opinion, I would love to hear it down in the comments section. But essentially, my understanding of Model-View-ViewModel is pretty much as follows. So whereas with Model-View Presenter, in my case, I would have a fragment, which is the view, and I would have a presenter, which is the presenter, obviously, in Model-View Presenter, and of course model, which is the model of the data. Some people would interpret that as the whole data layer of the application, but again, that's something that's somewhat open to interpretation. But the fundamental difference with Model-View-ViewModel and Model-View Presenter is that the view, which in our case will still be a fragment, and the view model, which in this case will be the ViewModel class from Android architecture components, it's important to note that while the fragment depends on the view model and can talk to the view model object, none of our view models must or are allowed to have knowledge or dependencies on the views which are using them. So what does that kind of mean, and how does that kind of work? So whereas with Model-View Presenter, this box here would be essentially we'd have one arrow going down talking to the view model and then another arrow going up talking to the view or the fragment. In this case, how the view model talks back to our view is it actually publishes data by way of LiveData, which is another API within our architecture components. And the fragment simply observes that live data. Now, we're going to talk about that a little more in depth, because if you're not really familiar with the observer pattern or how that kind of thing sort of works, we will talk about it in a little more detail once we're right into the code. But for now, suffice it to say that the most important thing is that this ViewModel object within its member variables should not have reference to a view. It should not have any knowledge of which views it's talking to. Rather, it should simply be publishing updates to the data which it contains, and the view should have some way of observing the sort of data itself, and that's basically how Model-View-ViewModel works. Now, within the context of this application, of course, we have our activity, which is simply a container. At most, what it will do is pass arguments into the fragment, and this is how I personally like to build applications, but there are multiple different ways. I like to have a 1-to-1 ratio of activities to fragments, for instance, whereas some people like to have one activity to multiple fragments. We're not going to do that, but again, if you feel like doing that, you're more than welcome to. And yeah, so we've got our activity, which is the container. We've got the fragment, which is of course the view. We've got the view model. And down here we have sort of our data repository layer. As far as what model is supposed to be, again, that's something which is somewhat up to debate. And I'm actually not really very fond of the name view model anyway, but let's not go there, Ryan. Our view model will have reference, or it will talk to this repository object. Now, why do we have this repository? Essentially what it does is it acts as a layer of abstraction between our database and our view model itself, but there's actually an extra layer of abstraction which we will be building next. And basically what that looks like, if I can kind of reposition this diagram here, is that the repository won't actually have a direct dependency onto our room database itself, but rather it will contain a data access object, which is what it will be using to sort of interface with the room database. Now you are probably wondering, why do we have this data access object and what is it? Essentially what it is, and it'll make more sense when we build it, is that it's a class which sort of allows us to interface between our Java code and our method calls. So for example, get me a list of data gets translated from Java into SQL through usage of both this data access object, annotations, and sort of room persistence library in general. So I just wanted to kind of give you an overview here, but like once we actually get into the code, I'll talk about it in a little bit more in depth, and it should start to make a lot more sense there. But the last thing to mention is that this data access object, these things live as member variables of our room database class. So kind of, although we're not depending directly upon this room database class, we are still sort of talking to the database in a sense through the repository. So that's kind of the general structure. Of course, I've left out entities, which is another part which we'll go over, but practically speaking, this is really the flow of the application. Of course, the activity launches, sets up the fragment, view model, and live data. These things get all synced up. The view model asks the repository for the data, and then as the usage of the application progresses, it will either tell the repository, you need to add an item, you need to delete an item, etc., etc. And that is essentially how our application works at a sort of 100 or 1,000 foot level. Okay, so the first thing we're going to do is we're going to set up our entity, which is the first sort of component, for lack of a better word, of the sort of room database persistence library. So what you're going to do is, from the previous code, we're going to open up ListItem.java. And within it, as you can see, we have a string for the date and time, a string for the message, and we've got an int color resource. And all we're really going to do is we're going to slap on this entity annotation. And so that sort of designates this class as an entity for room. And we're also going to set up a primary key. And so that's just going to be at primary key. Now, what is a primary key? In most cases, when you're working with pretty much any kind of database, you are going to want either a string or an integer or some kind of value which you can use to differentiate and sort of search items within your data store, whatever it is. So in this case, what we're going to be doing is we will use the date and time, which will be sort of accurate down to the second that the item is created, as a unique key, which we'll use to sort of store and retrieve the particular item that we create in. So for example, when I go to create an item, I'll hit the plus button, I'll go through the create setup, and it will create an entity in the database with this particular date and time. And that will then be displayed in the list activity. And once I click on a list item, it will pass only the ID, but not the whole list item itself, into the detail activity. And then the detail activity will use that ID to look up that specific primary key in the database. So that's kind of the main reason why we need this primary key here. So that's really all we need to do within the entity. Now, there are a lot more things you can do with Room Database as far as entities are concerned. There are sort of special setups you need to do if you want to include, for example, like something other than a primitive in here. What I would suggest to you is go ahead and check out the Room Persistence Library IO 2017 presentation. And they go into a ton of detail about all of that stuff. Really, the focus here is I just want you to have a working database that you can then play around with later on. So for now, this is all we're going to do in list item. That's it. Okay, so the next thing we're going to do is we are going to set up our data access object. So within the data package, I'm going to click on data source interface, and I'm going to hit Shift F6. And we are going to rename this as ListItemDAO. And then I'm just going to open that file up. So the first thing I need to do is, of course, I'm going to annotate this as a DAO, which is one of the annotations from Room. And so there's going to be a couple of changes that take place here, and this is where Room starts to get pretty damn interesting. So whereas before things were a little bit annoying when you wanted to set up a SQLite database with SQL Open Helper, you ended up with this, generally speaking, enormous class full of a whole bunch of SQL statements as string constants, and there's just a lot of stuff that you ended up kind of having to boilerplate in there, and it just overall wasn't a fun experience. You had cursors and databases you had to open and close and all these different things. And suffice to say, I'm pretty happy to see Room at this point. So let's kind of dive in here. So what the data access object does /is that it sort of provides us a way that the rest of our app can interface with the SQL stuff or the SQL database itself. And the way that we do that is we create basically these special methods and we annotate them. So for starters, what we're going to do is we've got this get list of data. We're actually just going to rename that to get list items. Not particularly important, but I just like to refactor code as I go. Now, in the old code, we had it just return a list of list items. What we're going to do now is we're actually going to have, pretty much all of the stuff that we're going to be returning, we're going to want to wrap it in LiveData. I'll talk about LiveData more later on. But we just slapped this LiveData with some angle brackets around whatever we wish to return. And that's basically all we need to do there, except we're going to also add a query. So we're going to type @query. Oops. @query, try that again. And so in this case, within this query, we are just going to type a little bit of SQL. So to get all of our list items, we are just going to say select from, oh, and that's supposed to be in quotations, list item. Oh, thank you for auto-completing that at the end of there. Perfect. Okay. And that's basically what our first query is going to look like. Now, the thing about this is you might be wondering, like, how does this thing even know? Like, how can I just type list item in here? Well, I can't really explain exactly how under the hood, but just note that each time we're slapping these annotations onto the correct sort of Java classes, like for example, we've annotated this as an entity. Basically how Room is set up is it's going to do a lot of pretty awesome sort of defaults. So for example, we can sort of choose to rename these entities. Like there are ways you could configure it to be something else. But in this case, it's going to just automatically know, because we have this entity annotation here, that list item is sort of the class that we're looking for. So if you're kind of confused about what's going on there, it's something that's sort of automatically generated, which is super nice. Let's finish off the rest of these. So we've got this create new list item method down here, so we can figure out a better way to do that. And so we're going to actually rename this, and it's going to use the insert annotation. Sorry. So what we're going to do is it's going to be within the insert annotations parentheses, we're going to set up what's, I forget the exact name, but it is sort of a, I think it's called a conflict resolution strategy. Let's just type it out and I'll explain what it is. On conflict equals replace. Hopefully it's going to automatically import that. Of course. Okay, so that's actually going to be dot replace. There we go. In the other project, it doesn't actually have me have to type the whole thing out. So, but yeah, it's a conflict strategy. So basically, all this is saying is if we pass in a list item to be created, and its Room sees that we already have an item with that particular ID, what we're going to be doing is just replacing that record. There are different strategies, but that's really going to depend on your implementation and what you're trying to achieve. So that is that. I will actually rename this just to insert list item. And that's that. The only other thing we need to do is return a long. So this is one thing which was something that takes some sort of fiddling around to do with, but how the SQL database kind of works is that let's say, for example, we successfully insert an item. What it should do is it should return you the, I believe, the number of the record that you inserted. So let's say we have 5 records and you insert one more. It should return 6. I might be slightly inaccurate on that, but basically the gist of it is that is one of the main ways that we determine whether the record was inserted properly. Although in most cases you can basically assume that it has been. And if I'm not mistaken, I couldn't find this exactly in the documentation, so I'm kind of just going off of my old knowledge of SQL OpenHelper, but I believe it will return something like -1 if it's unsuccessful. Although we don't really go into that very much in this tutorial because it's somewhat ambiguous. So that is our insert method. We only have a couple left here. So I'm going to add another query, and this query is for specific items. So we're going to type add query. The method itself is going to be return a live data of a list item, and this method is going to be called get list item by ID, and we're going to pass in string item ID, just like that. Within the query brackets, we're going to type some more SQL, but it's still very simple, and we're just going to type select from list item where item ID equals item ID, just like so. And basically what this little, I forget the naming, what the name of this is, but basically what this colon does is, basically this will sort of help Room figure out that we are comparing this value, which is the item ID, to this argument which was passed in, and that colon sort of designates that as, I'm such a visual person, but basically it takes what's in here and inserts it up here by way of the colon, and if there's fancier ways of saying that, I don't really know. So that's that. And then what else have we got? Should be delete. So in this case, we're just going to type @delete, and this method is going to be called void delete list item. Again, I think deletes will return some kind of value if the delete is successful. I think it returns the row of the item that was deleted, but this stuff was very ambiguously explained. The one thing I will say that was ambiguously explained, but you know, it's kind of edge cases when that stuff fails. And then what we're going to do is, this thing doesn't actually require any arguments there, but it does require, of course, the list item which we wish to delete. And I'm going to go ahead and delete that. I guess I could have just slapped the annotation on there. Now, we have one more, I think, or maybe we don't. Let's see. So we've got get list items, get item by ID, insert list item, and delete item. So those are all of the sort of SQL queries or commands that we are going to be using. Now, one little kind of note, obviously you might be thinking, well, how come we have to type SQL in here, but we don't actually have to type it with these insert and delete annotations here? And that's, again, just basically Room doing some of the work for us. It will basically figure out whatever SQL it needs to use in order to properly delete whichever item is passed in. And essentially that's the same result with this insert annotation. So really all that's going on here is they've kind of helpfully hid some stuff that we don't really have to worry about. And that's one thing I really love about Room, is that me personally, I am an Android and Java developer. I know a tiny bit of SQL, but it's not something I really care to use because it's just clunky and annoying to write. And so basically Room does a lot of the work for us. Also, one last quick little note, if I do happen to misspell something, or have some improperly formed SQL statements, we will get a compile time exception when we try, for example, to build the project. And that is very handy because they're usually really good error messages. Like, it'll tell you, I don't understand what fro means. So that's just another little note. So that's the data access object, and what we'll do next is we will set up the database itself. All right, so off camera, I deleted the fake data source class, and within this data package, I'm going to right-click on it, go to New Java class, and this new Java class is going to be called ListItemDatabase, and it is going to be abstract. That is important. And so what we're going to do with this class is I'm going to add another annotation, @database, and that is going to contain a list of the entities which our database needs to know about, which in this case is simply just ListItem.class. And then the other part we can add to this is the version, which will in this case be 1. Now, what is the version? And you'll notice, you probably can't see that, but there's another option for a parameter here, which is an export schema. So I'm not going to go into a lot of detail here because, again, we're just trying to get a basic working database for you. But just in a nutshell, as you can imagine, it is very likely that at some point you're going to need to change the underlying structure of your database. So for example, I might have to go in here and add another field to my list item. So when that occurs, in simple terms, what you need to do is you'll need to update, for example, the version to 2. Now things get a lot more complicated, and there's a whole sort of subject of database migrations which you could get into. We're not going to talk about that here, but just suffice to say that the idea here is that we want to avoid situations where you've got users using your app and then you change the structure of the database and you screw that up and then the users lose all of their data, because that is really, really bad practice. And there are different ways we can handle that, but one of the ways is simply once we change the database, we're going to want to increment that up each time we change the underlying structure or the underlying schema of it. So the only other things we need to do is we're going to say extends room database, room database. And also it does need to be an abstract class, that is important. And then the only other thing we need to do for now is we're just going to type public abstract list item DAO. List item DAO. And this is of course a method stub. And basically what that will do is it will provide a way with which we can hook to our database sort of through the data access object, which is sort of a member of this database class. And it's sort of another layer of abstraction, more or less. So that's all we need to do for our database. So these are kind of the 3 pillars of Room that you need to configure in order to have a working database. So we've got the database class, which lists the entities and holds the data access objects as abstract member variables. We've got the list item DAO, which basically is the way that the rest of our app communicates with the SQL database. And then we've got the entity, which are just our models of data. And from all of that information, the Room library will basically build all of the necessary SQL and all the crap that we used to have to do. It'll build a whole bunch of that stuff for us. So that's basically it, and let's move on. To spend a couple of minutes talking about LiveData. So the most important thing you need to realize about LiveData is that it's essentially a kind of observable. Now what that means is you can use it to sort of wrap data objects, and then other sort of parts of your application, in this case it will be the fragment, can actually observe these objects and sort of listen for changes and get updates to the data as they occur. Now the reason why that's kind of important is that it allows us to really decouple our architecture. Now you might be wondering how we kind of set this up, and I do have to admit, just because it wasn't really appropriate at the time, when I was drawing this diagram here, if I were to be like a little bit more accurate, the line going from to LiveData would almost kind of travel all the way down into the data access object. So basically what we're doing here is, like, in a way the fragment, like the fragment's going to talk to the view model and it's going to say get the data. What the view model is going to do is it's going to go all the way into the data access object, and by extension the Room database, and it's going to provide, we're going to kind of like relay pass the LiveData object all the way up here during the application's runtime. Now, the way we've got this thing set up, there's really not an especially great setup for sort of error handling and handling different kinds of events as the application executes, because we are trying to keep this really simple. But I just wanted to show you a second diagram, which was something I drew to kind of help me understand how these observables work. And this sort of extends to RxJava as well. Now, the way I kind of thought about this is, now this is kind of clean architecture, but if you imagine that your application starts at the front end and sort of events propagate down to the data layer or the service layer. I realize this is a really poor quality image, but events kind of propagate down here through sort of what I will call a request sort of event, and then at the other end of the database, it will either look up the data and then send sort of like a response event or a response object. And so if you're kind of wondering about how observables and RxJava and LiveData work, this is more specifically for RxJava here with these three sort of callback methods. But all I want you to imagine is that if we imagine this as different layers of our application, so we've got the front end, we've got, this is clean architecture, so there's a middle domain layer, but you can kind of just pretend that doesn't exist if you're not comfortable with it. And then we have the data layer, which is of course the database. So in our other Model-View-ViewModel application, of course this would be the front end and this would be the back end. And basically what happens is over time these different parts of the applications sort of communicate with each other by relaying these observables back and forth. So just one more time, let's say for example in an application the user clicks a button. A request is going to get sent sort of through the application, maybe to retrieve some item, let's just say. So it's going to get to the end of the application, which is of course the data sort of stuff, and it's either going to decide, hey, there is data, hey, there is no data, or there is an error or exception. And just be aware that having no data and throwing an error are not always, like, having no data is not necessarily an error. It might just be there's no records in the collection. And in some cases you'll have sort of you'll have events which need to talk to multiple backend services. So here we have service A and service B. And the point of all of this is that what makes this sort of reactive style and observable programming cool is because you can essentially, like, I'm trying to think of a good analogy, but you can almost like hike past these observables up to the front end. So even though the fragment in the front end is in a way sort of listening directly to the data, not super directly, but we'll just kind of say even though the fragment is kind of listening to that data directly, it's still properly decoupled from the rest of the application, especially when we're using LiveData, which is a lifecycle aware observable. So it's also, since our fragment is going to be observing the LiveData object, and the LiveData object is aware of this lifecycle, it's going to handle all of the really annoying sort of orientation change BS that you normally had to handle somewhat manually. So that's basically it for LiveData, and what we will do next is we will start coding our repository. The reason why I did this big diatribe is you'll see that our repository simply returns LiveData objects and basically returns them from the data access object. So I wanted to kind of set this sort of visualization up in your head that yes, our fragment is decoupled from the data, but by using this kind of neat architecture style and LiveData observables, I almost like to use the analogy, we kind of hike past the LiveData up to the front end of the app and it gets to observe it directly. Alright, so hopefully I've given you some kind of an idea of how LiveData works. Really, all I want you to think about is that it's going to wrap our data objects and allow them to be observed by parts of our application. So what we're going to do next is we're going to build our repository, and that should actually be it for our data layer. So on the data package, I'm just going to right-click, go to New Java class, and this class is going to be called ListItemRepository. As so. And again, this is going to be a pretty simple class to write, so let's just dive in here. First and foremost, our repository is not going to depend upon our database, but rather it will depend upon the data access object itself, which is pretty handy. So that's going to be private final ListItemDAO. And so what we're going to be doing is, just in order to have this thing just properly decoupled, we're going to use Dagger 2, and we're going to sort of use constructor injection to pass this ListItemDAO into the repository at the appropriate time. So what that's going to look like for now is we're going to type @inject, and then we're going to type just a simple constructor, ListItemRepository, and it's of course going to receive the DAO. That sounds kind of funny to me, receiving the DAO. It sounds like receiving some fundamental teaching of the way. Anyways, I'm tired, you'll have to forgive me. And then we're going to say this.listItemDAO equals listItemDAO. All right, so what we've done here is we have set up our listItemDAO within the repository. And really all I'm trying to do here is I'm trying to basically just use this repository as another layer of abstraction so that the ViewModel doesn't really know what kind of database or anything that it's talking to. It doesn't even sort of understand that there's a DAO in there, and that's sort of just data hiding in practice. It turns out that it makes the application easier to sort of change over time. Anyways, so there's a couple of different methods that we need to add here, of course, and those will be the methods present within our ListItemDAO class. So the first one is going to be getListItems. So what we're going to do is we're going to say public LiveData, and we're going to say list, let's see here, I know that's a little bit ambiguous, list angle bracket of list items, just like so. And as you can see, really all we're doing is we're just wrapping our stuff in a LiveData object. It's really as simple as that, which is pretty sweet. This method is going to be called, we're going to call it getListOfData, just to make it super generalized. And so what that thing's going to do is it's simply going to return listItemDAO dot getListItems. And that is all we need to do there. Let's just finish off the last few methods. It's pretty easy. So this one is going to be getListItem most likely. Let's call it getListItem. And so for getListItem, this method is going to obviously need to receive a string item ID, and that is of course the ID of the item with which we would like to retrieve. And that's going to be getListItem by ID, pass an item ID. And why is that screaming at us? It's screaming at us because we don't actually want to return a list of list items, but actually we're just returning a single list item, just like that. And then we have the delete operation. So we're going to call this method, let's see here, delete. I'm just going to actually write that from scratch here. So public void void delete list item. And we're going to pass in the list item to be deleted, of course. And then from there, we're just going to say listItemDAO dot delete list item, passed in. And insert is going to look pretty similar. Now, once again, I did mention this a little bit earlier, but we can actually choose to return longs here. Obviously, we can't do it because in the DAO, we're not returning that for the delete list item thing. But just be aware, like I'm just trying to give you a hint that if you do want some way of determining whether your item was inserted in the database or deleted from the database correctly, one way to figure that out is to look at the, you can either return void or you can return log there and sort of examine that, but I'll leave that as it is. Public, cool. And then this one's going to be, of course, insert list item. And I forgot to give that parameters in the data access object, of course. And so here we're going to type list item, list item. And so that's basically it for our repository. So before I close this little segment out here, I do want you to notice that, yes, we have had to create like 4 different classes to sort of set up our database. And there is some more configuration, especially with Dagger 2, that we'll have to work with. But for the most part, this has been very easy to set up. Like, this is the entire database class I've written. The data access object defines the different commands super quickly that I can sort of use to manipulate the data. And our entity has defined basically the structure of our table automatically. So yeah, it's, you know, Room database is pretty handy. All right, I can't seem to get a break today between seagulls and sirens and all kinds of crap that you generally get to listen to on a West Coast sort of hood area. But anyways, let's carry on here. So what we're going to do now is we're going to sort of add in the classes for the rest of our front end. Now, we're not going to write all of the code by hand on the front end because parts of it are just totally duplicated, but I'll show you generally how to, well, we'll go through setting up one activity, we'll create all the classes, and I'll show you how to do this kind of activity utils thing to sort of decouple some of the code, some of the boilerplate from activities into another class. So let's get started. First and foremost, let's finish off the create activity, or sorry, the create feature. So you're going to right click, go to new activity, empty activity, and remember that we've already sort of added in our layout files, so we will unselect the generate layout file thing right there, and app.compat is fine, and we're going to go ahead and call that create activity, just like that. Hopefully I didn't misspell activity this time. Excellent. Next, what we'll do is we will add in our create fragment. Again, select blank, and I actually like to unselect the factory methods and call. Actually, we can keep some of the factory methods, but don't do the callbacks because we won't be using them. And also, we've created that layout already, so this is going to be create fragment, and that's all we need to do there. And this stuff isn't especially interesting to you, so what I'm going to do is I'm going to create the activities and fragments and all that stuff for detail and list, and then we'll carry on from there. Alright, so I've gone ahead and I've created the rest of our classes for as far as containers and views are concerned. We'll sort of go over the implementation later, but just before that I want to show you a little trick which I picked up a little while ago. And so what we're going to do is, since each of our activities is going to have a fragment which it needs to inject, in my mind it makes sense to make some kind of an abstract class so that we don't essentially have to repeat this code in each of the activities, because we want to be good programmers, and you know, if we can have the activity sort of inherit this functionality, it's just better practice. So what we're going to do is right click on the util package, go to Java class, and this thing's going to be called base activity. It's going to be a class, of course. It's going to be abstract. And for the superclass, we are going to extend app.compat activity. Go ahead and do that. And it's only going to have one method in here. And that method is going to be public static void add fragment to activity. And that is going to receive a fragment manager. Sorry, there's some severe background noise outside. Anyways, we're going to add a fragment. It's going to receive a frame ID, which is just the ID of the frame which it's getting inserted into, and string tag. And so that's that. And what we'll do next is we're going to type fragment transaction. Make sure to select the support fragment transaction equals fragment manager dot begin transaction, and then we say transaction dot replace. We could probably use add instead, but replace works as well as far as I'm aware. And in replace we're going to say frame ID, fragment, and tag, just like so. And then finally we will say transaction.commit. Great. So what we'll do next is I'll only do this for one activity because it's not especially interesting, but let's go ahead and open up, for example, list activity. And so we're actually going to move all of this code that describes the view and all the view binding stuff into the fragment, but to be perfectly honest with you, I'm going to just copy and paste it from the completed code, and I would suggest you do the same because we're not learning anything here, you know, to do with Room Database. So what I'm going to do is I'm actually just going to clear all of this crap out, and we're going to make this thing almost completely just a container. as is desired. And let's just delete all of this stuff here. And we'll delete all of this stuff here. And boom. Now our activity is starting to look a little bit more like I personally prefer. And then what we're going to do is we're going to say, let's see here, fragment manager. Where is it? Support. Fragment manager equals get support fragment manager. We're going to say list fragment equals list fragment. Of course, we have to cast it because that's Java. And that's going to equal manager.find fragment by tag. Of course, we are going to create that tag, and that tag is going to be private static final string list frag equals list frag. Perfect. We'll slap in list frag there. And then what we're going to do next is we're going to do a null check. So we're going to say if the fragment equals null, obviously we need to create it. So we're just going to say fragment equals list fragment dot new instance. And then so either way, whether it's null or it isn't, we've got that thing set up properly. Why does that think it needs strings? It definitely does not, so I will go in and correct that in the fragment later. But for now, let's just finish this off. Add fragment. What was our... right, so what I need to do is, for each activity, we need to make it extend our base activity. And then, now that that's set up, what we can do is we can say add fragment to activity. And if I hit Control P, because I've forgotten the parameters, it'll say fragment manager. So we'll pass in manager. The fragment itself. And then the frame ID, which is going to be r.id.root activity list. So that is the root which our fragment will be inflated within. And then finally, we have the tag so that we can retrieve it. And so what you're going to do is for, of course, each of the activities, you're going to repeat this process with the appropriate fragment. As far as the keys, I just did detail frag and create frag for the other two. So go ahead and do that, and we'll start again. All right, so at this point, you should have all of your activities looking the same as the finished application. And go ahead and do that if you haven't already. I just copy and pasted it in, so I'd suggest you do the same. And what we're going to do now is I'm going to talk to you about Dagger 2 a little bit. We're going to have the Dagger 2 chat. So unfortunately, here's the thing about this. For people who are already experienced with Dagger 2, you're not going to have any trouble understanding what I'm doing here. However, if you're someone who's completely new to Dagger 2, which might be certain intermediate developers, even sort of a simplified implementation of Dagger 2 might be a little bit difficult to understand. The thing about it is dependency injection in and of itself is very, very simple. It's a concept that a child could understand. However, setting up Dagger 2 within the context of a complicated application and doing that properly is something which is quite complicated and difficult to explain. So what I'm going to try and do is I will explain it I will sort of give you my best attempt at a general explanation of Dagger 2, and we'll sort of do it with reference to the classes and the code that we need to create. But what I'm trying to say here is that you can take Dagger 2 a lot further than what I'll be demonstrating. And really all I'm trying to do is show you, okay, how can we get it like a very basic setup going where we are injecting into our, for example, repository, we are injecting into the view model, and we are injecting to the fragment without going absolutely crazy with Dagger 2, because there are implementations out there which are, it's almost like reading a whole new programming language, suffice it to say. But so really what I'm trying to say here is if you're a beginner and you feel a little bit overwhelmed or confused about Dagger 2, that's totally normal. You're going to need to go and watch some content on that because it really does deserve its own tutorial. But for those who are more experienced, you'll probably recognize that this isn't going to be like the most complicated setup, and I don't really want the Dagger 2 here to be really thought of as the optimal setup for Dagger 2. I really tried to go with simplicity over complexity here. So that's it. Let's get started coding it. Alright, so what I've done is I've gone ahead and I have copied and pasted in the class files for dependency injection, which includes application component, application module, and room module. And then I've also copied and pasted in the room demo application class. We won't be writing those by hand, but I will talk you through them. Now, as I said before, if you are looking for sort of a better and more complicated implementation of Dagger 2 that's sort of, I would say, more efficient, you're going to want to check out, there's this really awesome repository called GitHub Browser Sample. It's from within the Android architecture components samples. And what I'll do is I'll have a link in the description box down below. If I forget to do that, please do send a comment and scream at me. And that project is written by some really awesome developers, and it also demonstrates like a really complicated but awesome setup for Dagger 2. In this case, it's going to be just quick and dirty, so let's get started here. So basically, in most cases, how Dagger 2 kind of works is you want to be creating certain sort of services and things like the repository and stuff of that nature in a place of your application which sort of exists somewhat outside of the activity and fragment lifecycle. So in most cases, whenever you're working with Dagger 2, you're going to be overriding the application class and setting up some kind of a component. Now, there are so many different ways to set it up, and it's very configurable, but let's just, I'll explain how this thing kind of works, and then we'll deal with it later. So what I've opted to do in this case is we have two different component classes. So a component class is going to kind of list out the dependencies required for a particular object. And then we also have these module classes. And what the module classes do is they're actually responsible for creating the dependency or satisfying it. So how this thing kind of works is within our application class, which can be accessed from any activity or by extension fragment, we have this thing called this application component, which other parts of our app can get. So other parts of the app can say get application component. So what that will do is, as you see in here, when we create this thing, we create this application component with the application module and with this thing called the room module. Let's have a look at application component itself. So how you set up a a component in Dagger 2 is you specify a sort of, you can specify a scope for it. So in this case, we want this to be a singleton because there's only one application instance. And then what we do is we list off the modules which are sort of required in order to satisfy all of the dependencies in the sort of dependency graph that we'll build. Again, this stuff's kind of hard to explain. What I've also done, and this is like the big part that's not really that optimal, is we're going to be injecting into these fragments initially, and I've got kind of a what I would call a fairly tightly coupled implementation here because it does list specific fragments, but again, like this is a really quick and dirty implementation. So what goes on is when these things are created, they're going to sort of get passed in here or injected or whatever you kind of want to call it, and then Dagger 2 is going to sort of get to work looking through these modules to satisfy the dependencies for all of the objects that it needs to create at that moment. So what it's going to do next is it's going to, of course, look at like list fragment and create fragment and detail fragment or whichever. It's going to look at the one that we are currently working with. And then it's going to go in, and we haven't really written the view model yet, but the view model has something that's injected, and of course our repository gets injected with the data access object. So what we can kind of do is, in this case, I've decided to create a module called room module. This particular module class, and like I say, modules are responsible for creating / satisfying dependencies. What this module is going to do is it's kind of going to, in one place, provide everything we sort of might need to work with our room database. You might also call it something like database module if you want to be even sort of have more encapsulation and blah, blah, blah. But what this class does is we create it with an application instance, as so. And the reason why we do that is because the room database builder method, which is what we use to actually retrieve our database, requires an application to be passed in. So we pass that in and we create the database. And all is fine and fantastic there. Now for the rest of these methods, basically what they do is we slap this provides annotation on here. And so we're basically kind of telling Dagger, hey, if you want a list item repository, and all of our view models will want that, we will have inject in all of those view models. This is where you can get it. You call this method, I will give it to you. So that's pretty much what's going on with the room module here. So like I say, there's a lot of stuff going on behind the scenes that I'm leaving out here quite deliberately. But the last thing that I'll talk about is that when we get into our fragment and creating the ViewModelFactory, there are certain cases where we need to kind of use another sort of extra layer here to sort of satisfy the dependencies of our view models. So I'm not going to talk about that now in detail, but basically what that means is we are going to need to create a ViewModelFactory class. And we're going to need to sort of create our view models with that within the fragment. The application module is really simple. It really just provides the application class whenever that's needed. So of course our room module at some point will need to get a hold of that. And that is sort of the general, like the simplest and not great implementation of Dagger 2 that you could create, that will still help us get the database working. And what we'll do next, hopefully that's somewhat understandable, is we will get started creating our view models. All right, welcome back everyone. Well, as you can see, it is another day for me for this recording session. So two things that we're going to do. We're just going to make fix two errors that I caught myself already making. So we'll clean that up. And then what we'll do is we'll start work on the view models. Now we're not going to build all of the view models because A, they're actually pretty damn simple, and B, once I build one of them, you'll pretty much get the gist of it. But I'll take you through that, and then once that's sort of sorted out, then we'll start wiring our view models up with our fragments, and we're basically done at that point, well, until I debug and find all the other things that I screwed up. So carrying on, let's have a quick look here. So one thing that I'm not even sure how I did this, but this repository is of course supposed to have a method which returns the collection of data. I looked back on the footage before and somehow I managed to accidentally delete that, so that was kind of silly. So that's fix number one. If you probably caught this faster than I did, but just make sure that the repository has this get list of data method. And then the other thing we need to do is from the completed project, you're just going to copy in some scopes for Dagger 2, specifically the fragment scoped file, and just click and drag that and move it, or copy and paste rather, and you can just paste that into the util package, and that's just a Dagger 2 scope, nothing too special there. Why are you not behaving? Come on now. Copy and paste. Is that going to work this time? There we go. Yeah, and it's just Dagger 2 crap. Just make sure it's in there. And that's that. So what we're going to do now is we're going to set up our first view model. So what I'd like you to do is right click on the view model package, go to new Java class, and this class is going to be called ListItemRepository. Now So I won't say that I'm an absolute expert at creating these things, but I just wanted to give you a little bit of insight as to why I called it that and how I kind of decided that this was going to be a view model and things of that sort of nature. So basically, the way I think of view models is I'm going to be thinking, well, what kind of data do I want to represent in the user interface of a given feature of the application? And so, for example, with the list activity or the list feature, of course we need to display a list or a collection of these list items. And that's basically all we really need to display there. So I thought, well, that will become essentially what the view model for that particular view. And so let's go ahead and start writing it, and then things will make a little bit more sense. But really, there's different ways to approach it, and one of the cool things about using the view model pattern is that you can quite easily use these view models in different with different views, because there's no explicit dependency on a particular view. But my suggestion would be to just kind of play around with this and see what makes sense, because it is what it is. It's interesting. I've seen a lot of different ways to approach this, but let's just dive in here. So each of our view model classes is going to, of course, extend ViewModel from the architecture or the lifecycle package here. And then within each view model, we are going to give it a repository. So it's going to be private list item repository. And of course, we'll create a constructor. Now, just a brief note here. So we're not actually, so originally this project, I slapped on an annotation for Dagger 2 right in here for inject, and we were injecting, or so I thought, the repository. But the thing about this is we're actually going to be using a ViewModelProvider.Factory class, and that'll actually be what we sort of use to give our view model this repository at runtime. And that factory class will be injected into the fragment. So there is dependency injection going on. But I thought about it and realized that within the ViewModelFactory itself, we actually we don't even really, we just use the regular constructor with my current Dagger 2 setup. So longer story shorter, we are going to employ dependency injection. And that will, of course, we'll still inject the list item DAO and a lot of the other stuff, but the view model here itself, with this current setup, we won't actually inject the repository. But everything will turn out fine. Anyways, so we've got our constructor, and this thing only needs a couple of methods. And I think once we finish this class off, you'll kind of start to see how pretty straightforward we've sort of made our architecture. It's very well decoupled, and everything just sort of flows very nicely. So for the first method here, we're just going to call this, it's going to return a LiveData. Let me zoom in a little bit. So it's going to be public LiveData, and of course we're returning a list of list items, just like so. And then this method is going to be called getListItems, or getListedData, or whatever you really want to call it. It doesn't really matter. And all we need to do here is we're just going to say return repository.getListOfData. And that returns our LiveData object, which will then be observed by the fragment. And that is really that's all we need to do to get our list of data, which is pretty damn awesome. Now, this particular feature of the app does do one other thing. It allows us to delete items. And so that's one thing that we want to be doing on the background when we're talking to the repository and asking it to delete an item. So how we're going to solve that problem, and again, this is kind of a quick and dirty solution, but it's not that big of a deal. But we're actually going to create an async task. So this is going to look like private class delete item task extends async task. And for the parameters, we are going to pass in a list item as the first argument here, and then just void and void for the other two. And then, of course, that's going to ask us to implement the do in background. And all we're going to do here is we're just going to say repository dot, let's see here, delete list item. And then I'm just going to rename this to item. This is, of course, like an array, I forget exactly what it's called. I think it's like an arbitrarily sized array of items with this ... marker here. But all we need to do is just type item and then give it the index 0, and that'll provide the list item that we pass in the method itself. So that's all we're doing. So basically, I'm assuming most people are pretty familiar with async task, but there's really two things to note about it. All it really does is it provides an easy way to perform an operation on the background task, and you can have it call back pretty easily. Now, a lot of people used to use these within activities and things like that, and that can be really problematic because when you rotate, for example, the screen, it can destroy the activity, and if you didn't handle that properly within the async task, it might end up sort of either holding reference to an activity that should be dead, or it might call back to an activity which doesn't exist. And async task is something which gets a lot of flack, but in this particular case, like we've got it within a lifecycle aware sort of class here, the ViewModel. So that's the first thing. And secondly, we're not really calling back or anything like that. We're just saying, hey, run this operation on the background thread. So again, like in a real application, I would probably do this with RxJava, to be perfectly honest. But for the purposes of this tutorial, this will work fine. So that's one little approach there. And the last thing we need to do is, of course, write the actual public method. So that's going to be public void delete list item. List item. And let's see here. So that's just going to be, we're going to call this delete list item, or delete item task. And task equals new delete item task. And then all we have to do to start an async task is we just call task.execute, and we pass in our parameters, and we're done. So that is all we need to do within this view model. So what we'll do is I'll show you one other view model. We'll create that really quickly, and then we'll get into creating our ViewModelFactory class. And then the last kind of step, if I'm not mistaken, which I probably am, is we'll set up our views and the dependency injection. We're not actually going to be like writing out all of the code for the views, because do I really need to show you how to wire up a fragment to the view? But yeah. Anyways, moving on. All right, so I've gone ahead and I've copied and pasted in from the completed project the other two view models. And the reason why is I had a quick look at them, and they're like so simple. So for the list view model, which is used in the detail package, all it really does is it just gets given a repository, of course, and we'll talk about how to do that in a moment. How to set up the how to give your view models arguments when they're created, because there is a bit of a process, but all it really does is at runtime it gets given an ID from the view, and then it retrieves that. And as far as the create feature is concerned, all we do there is, of course, we have another async task, so that when we want to add an item, we just call that and insert the list item. And beyond that, it doesn't really do anything. So that's basically that. And let's get into how to sort of give our view models arguments. Now, the thing about view models is, as we'll see in a moment within the view, there's a particular sort of method that we need to use to create them. And just really quickly here, that method looks like this. So we call this ViewModelProvider.Of class. Now, initially we can actually just supply it with a single parameter, and this would just be the context of the activity or the view, or I guess the possibly just the lifecycle owner in general. But when we want to sort of give a view model a class sort of as it's created, so for example, we want to be giving it a repository object, then what we can do is we can set up these ViewModelFactory objects to sort of create these view models with the appropriate arguments as we see fit. So what we'll do now is we will code the custom ViewModelFactory object. So you're going to go to the ViewModel package, right-click on it, go to New, Java class, and this class is going to be called Custom View Model Factory. Go ahead and create that. And so this class is going to implement the interface ViewModelProvider.Factory. And of course, you're going to hit Alt-Enter and implement methods. And that's going to give us this create interface method here. Now, before we get to that, there's a couple of things we need to add in. So this ViewModelFactory is going to contain the arguments which we wish to give our each of our view models, which in this case, they all want a repository, but you know, if there's going to be a lot of different cases where you want to be providing your view models with stuff when they're created, and this is sort of the main way that you're going to do that, just as a general hint here. So what we can do here is private final list item repository, like so. We're going to call that repository. Of course, go ahead and give it a constructor. And so what we're going to do in this ViewModel class is we're going to come down here and say, and this is a bit of a mouthful here. So how this thing kind of works is it's going to be sort of given a model class of type T. And what we're going to do within this factory class is we're going to need to determine which view model we are sort of creating. And so it is a little bit of boilerplate here, and what that's going to look like is we're going to say if model class dot is assignable from, and for each of these we're going to list off all the different classes we have, which are our view models. So the first one's going to be like list item collection view model dot class. So if that is the case, then we're going to say return. And we're going to cast it to type T, new list item collection view model with the repository. And so that's sort of how we create these view models with the repository proper. And so we're just going to select that and hit Control D twice and just kind of reformat things. Just like that. And this is going to become else if and else if. And for this one, we're going to say list item view model. List item view model. There we go. And we'll, of course, cast it properly down here as well. List item view model again. And this one down here is going to be new, let's see here, new list item view model. Just like so. And of course, we need to sort of throw an error in the event that we have not listed all of, or sorry, in the event that we provide a model class which is not listed within this factory sort of control logic here. And so what that's going to look like is we'll just say else throw new illegal argument exception, and that's just going to say view model not found. Just like so. And so that is the setup for our ViewModelFactory class. So like I say, this is going to be how you create your view models with arguments. Now once again, I do have to mention that if you check out the GitHub browser sample from the Android, I believe it's the architecture components samples, whatever, link will be in the description box. It's going to show you a much more sort of complicated setup. Again, I kind of wanted to keep things very basic here just so that we didn't get lost in a little bit too much complexity. But there's a lot of stuff like you could inject in here, and you could do a lot more work with Dagger too. But for the time being, this is how we're going to be creating our view models with the repository at runtime. And what we'll do next is we'll see how to wire everything up within the view. This is it. We're so close. Okay, what we're going to do now is we are going to wire up our list fragment to the list view model. And once that's completed, we're going to run a test of the application. So what I've done here is I've actually pretty much just set this thing up so that it's got all of the view boilerplate, all of the stuff that just sort of wires up the view to the XML layouts and all that stuff is already just copied and pasted in. None of this is new, none of this is interesting. It's just like wiring up layout inflators, it's setting up the recycler view, a custom adapter. If you're curious about how to do that stuff, you need to watch the RecyclerView tutorial, because that's where I explain how to do all of this RecyclerView setup, including the swipe to delete pattern and all that kind of stuff. Now, what I have removed from the copy and pasted code is the stuff that we're concerned about, which will be how to set up the dependency injection, how to create the view models, and how to sort of deal with them at runtime. So let's get started on that. So the first thing is we are going to be injecting our ViewModelFactory class. And the way that we do that, of course, is we say @inject, and then we say ViewModelProvider.Factory, which is the interface. Then we say ViewModelFactory. Just like so. And of course, if I open up our Dagger 2 stuff, just up in dependency injection, and I open room module, you'll notice that the factory that we create is, of course, returned as an interface, which is the ViewModelProvider.Factory. So that's how we get away with doing that. Now, we're going to inject that, and we are also going to, of course, hold on to our list or our view model as a member variable. So that's going to look like ListItemCollectionViewModel. ListItemCollectionViewModel. You could absolutely name it something smaller than that, but I don't really personally care. And great. So the first thing we need to do is within onCreate, we need to sort of get a hook to our actual Dagger 2 application component and just make sure that that's working properly. So the way that we do that, again, with a very rudimentary Dagger 2 setup, is we're going to say we need to cast it to room demo application. And then we say getActivity.getApplication. The next thing we're going to do is we're going to say .getApplicationComponent. Then we call .inject. And we're, of course, going to make sure that, well, it doesn't actually matter which one we select because we just passed this. And just one more time, if you're, well, I'll just take you through the Dagger 2 stuff really, really quickly one more time just to summarize. So our application is kind of like it's kind of like the hook to our whole dependency injection graph, or however you want to explain it in simple terms. And then it's going to go into the application component. And of course, we've got our fragments listed here. And then through there, through some magical stuff, it's going to look in application module and room module and satisfy the different dependencies that it needs. So it's going to come in here and see, oh, I have a ViewModelProvider.Factory. Let's go ahead and get that. And that's how we're going to sort of inject into this fragment. Now, there are, like I think I mentioned this before, but there are actually like, there's a dedicated, I forget exactly what it's called. It's something like a fragment injector, and you can use sort of more dedicated stuff for Dagger 2, and I just really want to give you a heads up on that, that this is not necessarily an ideal Dagger 2 setup, but what it will do for us is we'll be able to inject into the fragment, and it's going to work. So it is what it is there. So we get a hook to our application component, and we call this inject method, and that satisfies our dependency injection here. Everything should be good. Now the next thing we're going to do is when we want to sort of create our actual view model, we're going to want to do that in onActivityCreated. And the way that we're going to do that is we're going to type ListItemCollectionViewModel equals, and we're going to say ViewModelProviders.of. And what we're going to do is we're going to supply this, and we're also going to supply our ViewModelFactory object. And if you remember, that thing was created with the repository. And then all we say is .get. And of course, we supply the ListItemCollectionViewModel.class parameter. Perfect. Now, just one really quick thing that I mentioned. I left a note up here, but this fragment and the other fragments currently extend the lifecycle fragment. Now, according to the documentation, there's going to be an update to, I think it's support fragment, but there's going to be an update to the standard fragment classes, which will mean that you won't actually have to use this lifecycle thing. So eventually you should be able to just type fragment and that'll be fine. But at the time of releasing this tutorial, we have this lifecycle fragment, which is a temporary class. So just giving you the heads up on that. So we've created our view model, and this is how you want to be creating your view models. We say view model providers of this view model factory, and so this sort of handles the proper creation of our view model, and the factory allows us to give our view model arguments as it's constructed. And the last thing we need to do is to actually set up our observer pattern. So if you're wondering before, like, okay, so how does the view actually kind of listen, or how does it become an observer? And once again, it's pretty damn straightforward. All it looks like is we say list item collection view model dot get list items, and of course just do take note that that is returning a live data object. So remember, as I said before, I almost kind of think of it like we're kind of passing a live data sort of bundle up to the front or the front end of the app, and then the front end of the app is just going to be observing that object. So we say get list items, we return the live data from the data access object, and then we call dot observe. And of course the parameters for that are a lifecycle owner, which is of course our lifecycle fragment, or for you more likely just a fragment. And that means we can just type this. And then we say new observer, and it's going to auto-complete it for, let's just see if I can clean this up a little bit here. It's going to know that we're working with a list of list items. That's all great. Then we have this method onChanged. And so all we need to do now is just a little bit of checking here. So we say if list fragment dot this dot list of data equals null, then we say set list data list items. And so the reason why I do, I'll talk about why I do this null check here next. So we're almost done here. So what we've set up is our view model is now, our view is now observing our view model. So we have established the Model-View-ViewModel sort of communication through the observable setup. So what we can do now is, because our view does have reference to a view model, it can make calls to this view model. However, when it wants to sort of how it knows that the data needs to be updated is it observes the data from the database rather than a message from the view model saying, hey, you need to update this data. So that's what's going on there. And the last thing we kind of need to set up here is our swipe to delete functionality. So we're going to go all the way down to a specific method here. So way down towards the bottom is our item touch helper. And this is what we use to set up the swipe to delete functionality. Let me just find my place here. And so what we're going to do is, of course, in the onSwiped method here, callback, it's going to give the position of the item that was swiped, and et cetera, et cetera. And what we're going to say is, we're going to say list item collection view model dot delete list item. And then all we do here is we say list of data dot get position. So this will retrieve the item of the swiped, the item based on which part of the recycler view, which item of the recycler view was swiped away to be deleted. And so what we do is we remove that item from the sort of temporary list of data within the view. So we delete that. We say to the adapter, hey, this thing got removed. And so up here, you'll notice that I did that little null check just before resetting the data. And the reason why is, if for some reason, I'm pretty sure what would happen in this case is when we do delete an item, it would call back the onChanged callback here. And we don't actually want to be like sort of wholesale resetting this list of data, because we've already made it consistent with the underlying data set just down here by removing it just with these lines of code there. So that is setting up, that is wiring up our view to our view model objects. And what we're going to do next is off camera, I'm going to just copy and paste the code for the other two fragments, because it is the same code essentially. And then we're going to sort of do a quick recap. We'll do a demo, see if there's anything I screwed up, and that'll be it for this tutorial pretty quick. All right, so I went ahead and finished off the code for the other views, so they're all working fine. Now, one thing I forgot to do is I actually forgot to rename this one particular field of the list item. And so what happened was I went to build the project, and it gave me a particular error. I'm not sure if it will anymore, but the messages that it told me was basically, hey, we're looking for this field item ID within list item, and it doesn't actually exist, so what gives? So basically what it's saying is my schema is wrong. I have incorrectly sort of set up this database, and let me just show you really quickly. In the data access object, we're working with this field called item ID, and that isn't actually a field within our entity. It actually says date and time. So the way that we're going to fix that is I'm just going to double click on this, hit Shift X F6, and we're going to rename it to item ID, like so. I'm going to hit Tab, and we're going to rename everything, of course. Select all, hit OK, do refactor, and we'll see if that works. All right, so that did appear to fix the SQL issue. Also, what's going on is naturally when you're doing lots of copy and pasting, or you're working with code base from an old repository, then you're going to get import issues. So anytime these import problems pop up, like for example, here it's telling me the logic package doesn't exist, all we need to do there, and you can kind of get in the habit of doing this anyway, is we're going to hit Control-Alt-O. And what that's going to do is it's going to clear all of the messed up and unused and erroneous import statements. And that's how you fix errors like that. So once again, we're getting some errors, and this is caused by this controller unit test class, which is again from the old tutorial. And I'm going to solve that by deleting it. And we'll see how things go from there. All right, everyone, we've got the project building. Now, we're not out of the woods yet, but there is a small chance that when I hit this play button and deploy the application, that it might actually work properly for a change, but we'll see. Most likely there will be some other errors, but let's just give it a shot here. Deploy it to my emulator. Excellent. Don't worry, this happens every time I do the tutorial. Okay, so it's telling us class cast exception. So application cannot be cast to room demo application. So I'm going to go see what the problem is there, and then we will try the demo again. All right, this is a tricky little error, but luckily I have seen it before. So what it's doing is it's saying, hey, you can't cast activity to room demo application. Or sorry, cast application to room demo application. Now, the first time I got this error, I of course looked at my room demo application and saw, well, yeah, actually I most certainly can cast it to room demo application. However, that's not the issue. The issue is that when you extend the application class, you need to add that to the manifest. So I'm going to open up the manifest tab, just like so. And let's see here. What I need to add is within the application tag here. Sorry, there's a whole bunch of background noise outside. Perfect timing. What we're going to do is we're just going to add a thing in here. So we're going to say Android name, and this is how we register our application class. And let's see, does it give me the... Hopefully it'll auto-complete it for me, but that'll be .room demo application. And so yeah, that's how we register the application, our custom application class with the Android manifest, and that should get rid of that error. So let's see how things go from there. All right, I have updated the manifest, and let's see what happens now. All right, well, it's building, That's a bonus. It has an item already in there. So the first thing I'm going to do is I'm going to try and swipe to delete this item. And it does appear to be working. Let's try adding an item. Okay, that's looking how I want it. Let's go with green. And for the message, we're just going to say, holy crap, this has been an incredibly long and difficult tutorial with over 20 segments and 100 takes. And that'll be my little message. And we'll hit the check mark to see if it works. And it does appear to be working. Let's add one more item, another message, and add that in. And that's looking good. Let's swipe to delete one more time. Okay, and the final step, if this works, we are actually kind of done here. Oh, and it works. Holy crap. So that is our application. It's functioning. I'll be back in just a moment when I maybe take a power nap or something like that. All right, everyone, thank you so much for watching. I would say it's been fun, but, well, it has been fun, but it's also been really time-consuming. But, hey, hopefully these tutorials are useful for people. I try to do things a little bit different and basically try to not only build my own code. Obviously, you know, this is heavily referenced by the excellent code repositories, which are listed in the sources and inspiration section of the repository. And I'm greatly appreciative to all the people, particularly one thing I just wanted to kind of mention here in this outro is that I've been sort of self-taught on Android since 2014, summer of 2014, and it's been really incredible to see like the shift of effort that the Android team has sort of gone from, and I'm not trying to crap it on anyone, but to give you an example, like trying to learn how to do an SQL-lite database as a beginner was a really frustrating experience. And comparing that with the experience I've had with Room and ViewModel and LiveData and all these things, with all the excellent code labs, all the good code samples, all of the I/O talks, it's been a difference of like night and day for me learning this stuff. So I just really want to in this case, take my hat off to the Android team and all the developers that have contributed alongside. I know that there's lots of GDEs and stuff like that have also contributed to the code samples. So thank you so much. If there's anything in this tutorial which strikes you as being just like flat out wrong or inaccurate, then feel free to let me know. Bring up an issue in GitHub. Also do keep in mind that there are certain things in here which I did very deliberately keep simplified. For example, the Dagger 2 implementation is a good example of that. However, with that being said, this tutorial series isn't completely finished because there's a couple of things that I would like to partly readdress in another video. And also there's some sort of new things which I want to add in. Most importantly, I'm planning eventually, and I give no deadline for this because this project itself has gone on a lot longer than I really had time for. But eventually I'm going to be implementing, of course, data binding within this project, and I might add a couple other things in here. But that's it. Thank you so much for watching. If you do like what I do and you found this useful, please consider supporting me by throwing me a $5 on Patreon or something of that nature, or checking out the link in the comment section down below for more options to support me. And if you don't want to support me monetarily, that's totally fine. If you just want to like and share stuff, that helps too. And if you don't want to help me at all, then that's fine too. Do whatever you want to do. Thank you so much for watching. Hopefully that was useful. See you next time.